you something about lab test 3. I would like to give you an introduction about it first, and afterwards we can talk about your questions and also your questions about lab test 2. So I think it's best if I first show you a video on what you are supposed to do. I will therefore share my screen and explain what you will need to do. So today, or for this lab test, I need you to sort, or the robot, to sort balls, colored balls. They could be either blue, red, or green. Let's just start the video. It's without sound, so don't worry. So the robot comes, grabs the first ball, it's green, and it puts it on a scale. And you see, I will just stop it at the next ball. Like you see, it puts it like this here is, we call it scale. This is the position where the robot is currently at. And this scale checks the weight of the ball. So each ball, like a ball with the same color, has the same weight, but each color has a different weight. That's how we do it in the real robot, in the real robotics lab. So we have heavy tennis balls. We have like filled with sand. They're quite heavy. We have light balls. They do not contain much sand at all. And we have medium weight balls. So the plan, or this position is to check out which weight, or in our case, which color. There's no camera, so the color is just for you. The ball has. I will explain it more in detail on how you do it later on. This here on the right-hand side, where you can currently see a blue, a red, and a blue ball, we call the feeder. And here you have 3 pellets where you pelletize the balls according to its weight. So now it takes a blue ball, and somehow it seems that if you watch the blue ball, that it puts it only on one scale, whereas if it's a red or a green ball, it needs to put it on both plates of the scale. It will become more obvious if I show you how, or as soon as I show you how the scale works. Okay, we go on like this. Let me just run it a bit quicker. And you see the robot is filling the pellets always with the same color or the same weight of the balls. And you see here on the right-hand side, the person who has created the code always creates more balls. It seems that we're never running out of balls. Whereas in reality, of course, we only have space for 8 tennis balls in our feeder, but not more. But here it's not a problem to recreate balls over and over until our program ends. Okay, now you will see that the robot will stop. Why does it stop? It stops because one of the trays, one of the pellets is full. Here it was, let me just show you this last picture again. Here it was the red tray, which was full. So the robot stopped its sorting and did not continue with the green or blue balls. So this is one break condition. Your robot stops sorting as soon as one of the trays is full, no matter which one. A second condition could be that the balls in the feeder are empty. If the robot cannot sort anything, there is no reason for it to continue. So this is your second break condition. Your robot continues sorting balls until either one of the trays is full, no matter which one, or the balls are empty, like in the feeder, no more balls. Okay, let's have a look at the questions in the chat. Yes, Mr. Nguyen, that's true. For the blue one, it uses the scale-only ones. Why that is so, I will show you later on. We do not have a feeder that feeds the feeder. And having a person feeding the feeder would be too dangerous because it's very close to the robot. Yes. Third question, the color balls have different weights. We have, just to you, in this MATLAB online course, we have given different colors to the balls. In the real robotics lab, they're all yellow. They just have a letter written on it if they are medium, heavy, or lightweight. So, but here we don't have a camera, but we sort them by their weights because the scale can detect weights and no color.
Does the scale communicate with the robot?
Yes, it does.
Just measures it.
It measures the weight. I will just show you later on. This is the reason.
Idea, but I'm not sure how it works.
This is the reason now why we asked you to create or to learn how to use digital inputs and loops during MATLAB Access or the robotics exercise 2, because this is what you're going to need now. Yes, in the real lab, we have 3 different weights and 3 boxes. Like the trays look identical. Like they are also sorted in a specific order. So we do not just throw them in the box, but there is a tray where we can palletize them nicely. Let's have a look at the code. Because there is some code already given. Like here you can see the description. We can have a look at it later on. The code is given, like here, I'm in my QKCP folder, and there is a file called ballsort2.m. This is already given to you. Please use this to create some more code. So I have already opened it here, and I have already set some breakpoints, like stop points, to be able to show it to you properly. So let me just click on run. Okay, so you see, we start here, we have only KUKA home created, and here I have created several points. So you do not have to create any points. They're all given. You just have to use them. So, here we start the QKCP, and this here is for showing the different points. Here is a pause. This pause means MATLAB will wait until you tell it to continue. So I have to go to command window and press any keys. Yes, those points are related to positions. You can already see it here. Those points here you have given are the points we have created already for you. And those are the ones you use to do the movement. You will see just in a couple of seconds. Okay, so here I create the data, the tool and the base is already created for you. You don't have to do anything like this. Okay, now our robot starts moving. We tell it, please go in home position. Although it's already there, this is what we do in every robot's program. We first ask the robot to go home in this position. Then this position or this command is to open the gripper. Like you see, there's a blue, like in the in lab 1 and 2, we had a cone as the tool. Now we don't have the blue cone anymore, but we have a gripper to grip the balls, and it can open and close. It of course needs to be open to be able to grip a ball, and that it can hold the ball, you have to close the gripper before you go away from the ball. Let's have a look at this. Okay, I opened the gripper. Saw that, it just moved. Now my robot moves to the position OF. OF stands for F for feeder and O for oben, like up. And next move, it's a PTP movement. You know, we can move far away from obstacles. We use the PTP movement, and as soon as we're close to obstacles, we have to use the linear movement, as you have done in exercise 1 and 2. So now we move to the feeder, like the lower point. It's just very close to the ball. Okay, and now we want to grab a ball. So we close the gripper. We take a short break, because in reality, and also here, closing the gripper takes a couple of milliseconds. So if you're too fast, you don't make the robot wait for a second or so. It will just go away without the ball in the gripper. Okay, now we tell the robot to go up again in the linear movement. This is very important that you always move far away from the obstacles. Like if you move like where you have the lower red ball just straight to the scale, you would crash into something. So that is the reason why we move away from the feeder, go to above scale 1, and then move down again. Okay, now we're above the feeder. Like here again, we have here W1 for scale 1. Scale in German means Waage with a W. That's why it's called W1. And O again means oben, like above or up. This here is, the robot will not do the placing on the scale for you, like not with the given code. This is a task for you, but it would be Kuke.lin U, like unten, W1 would be the position down here, and here the UW2. You can either see it here, or you can also have a look at it here. So, how to get the scale, how to get to know which weight it is. Let's have a short break in here. Let me just open, let me just open Paint. And I will just draw a scale. Okay, let's imagine this here are the two scales. Let me just call it, this here is W1, so this is the first I do. And this here is the second one. So I place my ball. Let me have a nicely colored ball. I put it here on the first scale. My ball has a weight. So if my ball is light, it will not push the scale down, so there will be no signal at this weight one. So it's like I think you call it dead man switch. Like maybe you remember from boats, like we always have to push a switch, and if the person does not push the switch anymore, that person must be dead. Okay, so no one is moving, is steering the boat anymore. So then there will be an alarm. This is where the name comes from. So we place the ball on scale 1. If it's a light ball, we don't get a signal, but we know there is a ball. That means it must be a light ball. Since I know this information, I don't have to check with scale 2, because this one here, scale 2, is less sensitive. So if I do not have any output, like output being false at scale 1, I will never ever get any true at scale 2. So I can just ignore putting it on scale 2, and putting it for light balls on weight 1 is enough. Let me just write it down. So it's a light ball. All up. Let's do a 1 here and the scale 2 here. So this gives a 0. No signal. So I will not check for scale 2. If it's a medium ball, I will put it on scale 1. Or if it, like, in every case, I put it on scale 1. If it's a medium ball, it will give me a true here. And since a heavy ball is even heavier, it will push the scale even further down than the medium ball. It will also give a true for scale 1 for heavy balls. So we have the medium balls and we have the heavy balls. They will both give a true on scale 1. It will be pushed down so much that our sensor reacts. Now we have to figure out, is it a medium ball or is it a heavy ball? That is the reason why I have a second scale. I will then, therefore, put my ball from position 1. I will now put it on scale 2. On scale 2, the ball also pushes down, and if it's heavy enough, I will get a 1 as a return value. But for scale 2, I need a really, really heavy ball to get a true here. So only heavy balls are able to give me a sensor signal of true for scale 2. The medium weighted balls will give me a false. Okay, so Light balls, I only check scale 1 and I will not have a signal. It's not heavy enough to push the dead man switch down so I get a signal. So then I can stop. For medium balls, I will first put it on scale 1. I will get a signal. And now I have to check, is it a medium weighted ball or a heavy weighted ball? So I put it on scale 2. If I get a signal, like I get as a signal, I get 0, no signal. It was a medium ball. And if I also get a true on the second scale, it was a heavy ball. So I have to then sort it as heavy ball. That is the reason why we only place the blue ball, which is the light ball, on scale 1, because it's enough for us to figure out which ball it is. Okay, let's continue in the code. Now we have figured out which ball it is. I can now sort my ball. There I have created, or the professor has created a function called palette, a tray, palette here. And it will sort, the ball according to the result you have given or you have received here from the scales. So it has one output signal, which is also an input signal. You have pos 1, and you have a variable here we have written down 1. So this is the one you have to use to change, to sort the balls. So you have figured out it's a light ball. I want it to be then in tray 1. So you will write a 1 here. So we have 1, PAL 1 is this one, PAL 2, you can see it here, is this one, PAL 3 for the heavy balls is the third one. So if you think it's a light ball, you write a 1. If it's a medium ball, you write a 2. And if it's a heavy ball, you write a 3. The pos returns or uses the position of within the tray. This is nothing you have to do. This is calculated automatically by the program Palette. The value count ball is the number of balls, or is the position of the ball you want, or like the number of ball you're currently pelletizing. So this is a variable you have to create, you have to define or declare, and also give a value to. So this is the first. If you want to, if you want the robot to say, yeah, it's the first ball, and I want it in position 1, you write a 1 here. If you just don't want to start at position 1, but maybe start at position 10, be here, here, you could also start with a 10 here. But this is just for testing purposes. So in general, you have to create 3 variables: count PAL 1, setting it to 1, count PAL 2, setting it to 1, and count PAL 3, also setting it to 1. So the robot will start pelletizing here in this corner, and also in this corner. Okay, so now our robot will pelletize our ball at the first position of probably still pellet 1, because I have made the changes after I started running the program. So not to confuse you, I just put it back as 1. You see? if I now call the code, it does everything for you to place the ball on tray 1 at position 1. Now, since you also have to do something, the example program stops now. The robot will go home and we'll have another break. And now afterwards, I'm going to show you some more interesting values. Okay, now we're back home and we're again in a pause. So I have to go in my command window and press any key. And now we are here back. So now I can read a signal. It's called signal feeder, and it tells me, is there a ball available? Is there still a ball in the feeder? If we have a look here at it here, we have still one ball. So the return value, if I continue, you can also see it here in the workspace, is it true? Yes, I still have a ball in the feeder, so no reason for me to stop the sorting process. Those two are the values for you to read the scale. Currently, there is no ball on the scale, so the return value are both 0. If there were, for example, a heavy ball on scale 1, it would return a 1 for value 1. And if we then place it on scale 2, it would return a value at 2. It's very important that you store those values, or that you check the scales and save the value while the ball is on the scale. Because as you see now, if I now ask for the scale value, it will tell me there is no ball on the scale, it's all 0. So you have to do it while there is a ball on the specific scale, and you have to remember it by writing it in a variable. Here we have given you some further hints, like if-else statements, the for loop you already know from lab test 2, while condition, like robot, do your sorting while there is still a ball in the feeder, and while there is still space in all 3 trays. And if you want to, for testing purposes, if you want to, if you want to display text or values on the command window, you use this disp function. Okay, I would now stop the recording and ask you to ask questions about lab test 2 and lab test 3, and then start working on it. And do not forget the lab test 2, the documentation is due on Sunday. And there is one thing I currently just forgot to tell you, is I need you to create a flowchart. Yeah? Before you start programming, create a flowchart, what the robot is doing, how long is it doing, when does it stop, which points, or what is the robot doing, like it's first going to the feeder, then it is doing the scaling thing, and all such as a flowchart. And please believe me, I've once tried to do this, the robot program, after I haven't done it for a while without flowchart, it was a mess. It takes so much more time if you did not think about it beforehand. So do yourself a favor, do me a favor, and create a flowchart first. Additionally, because we need you to submit it in the documentation, so you have to do it anyway. So do yourself a favor and do it before programming. Yeah. Here in the in the description, there is the same code given. I've just showed you. Here is again the scaling, how you do it. Also the comparing between the real robot, the real robotics lab, and now this MATLAB robotics lab. Yeah, and here, very important, you do not have to create further movements or further points. Two things. You do not have to create further points, and additionally, do not create movement commands in QKCP. We do everything in here. Points are all given, and we just use them by creating code, creating the movements in MATLAB itself, as you did in exercise 2 mainly. Yeah. I also need you here. I need you for documentation. Add your code, comment it, write some text about it. And if you want to, you can add, submit a video of your result of your robot moving. That will be also very helpful for me. And create your documentation such that someone who has no clue on what to do knows, can follow can take your documentation and follow it step by step and just do the lab. So I will now stop the recording and you start asking questions. Okay.
Okay, so I also have to provide a flowchart?
Yeah.
Okay, cool. Like, for example, in the flowchart, should it also implement the decision making on the scale, or should, for example, the decision making of the scale be one big block? Or do you need like syntactical?
I think it's easier for you if you just put it in 2 parts, like put it on scale 1 if it's scale, like, because if it's a light bulb, you only do scale 1. So it's much easier for you to write down, put it on weight 1 if it's a true, put it on scale 2 if it's a false, continue palletizing.
Yeah, all right, okay, thank you.
You're welcome. The flowchart is only for experiment 3. No flowchart for experiment 2. Oh, sorry, there was a question in the chat. Okay. Further questions? Also questions about exercise 2, if you want to.
Okay, so I have a question about the exercise 3.
Mm-hmm.
So about the weight of the ball. So if you use the points like this unten points on the weight, it will be automatically measure the weight of the ball, or do we have to do something additional?
No, you do not. Like, let me just like you put it on the scale. Oh, one thing I forgot is of course you have to open your gripper. Like, you put it on the scale, you open your gripper, and then you just ask for I'm sorry, you just ask in your code for this variable or this function call.
Okay.
And you take the return value. Like, you take value 1 or value 2. And of course, before you leave, you have to close the gripper again. Otherwise, you will not take the ball away.
Okay, perfect. Thank you.
You're welcome. So we'll just do one more thing in the recording, what I just told you. Just an additional remark. If you are if you're putting the ball on the scale, you have to open the gripper. Otherwise, you will probably not get the correct result. because it could be either that the gripper is pushing on the scale, then you will always get a true, or the ball is still somewhere in the air, so you will always get a 0. So it's not sure that the result is correct. So it's very important. Put the ball on the scale, open the gripper, wait a second, take the signal of the scale, then close the gripper again and continue. Okay, is there any further question? Your cookies CP?
You are now muted.
Sorry, I have a question.
Yeah. Okay.
So when's the deadline for the task number 3? How many?
It's in June. I think it was end of June.
Okay.
Like
So
we're going to meet for, let me have a look. We're going to meet for 3 weeks doing this. Like for you, it's 18th of May, 1st of June, 8th of June. And I think then it's another 10 days or so until you have to submit it.
Okay, thank you.
You're welcome. You can also see it on Moodle on what the deadline is. It's in 40 days on 27th of June.
We're still streaming, by the way.
You do not have to upload any MATLAB file for task 2. What I need you to do is you create a document. In the end, must be a PDF where you insert your MATLAB code and describe what you were doing. Add some screenshots so you do not have to, or you should not even submit an extra MATLAB file for task 2.
You are now unmuted.
Oh, you cannot see task 3. This has nothing to do with uploading exercise 2. Did you ever try to like those tests? Let me just share my screen. Like there are all those questions. No, not here. Those steps. Did you try to confirm them? Does it work? Like, will you see more steps down here? Like the upload is here in 12 and 13. Okay, if it does not work, tell me. I can set it free, like open it manually if it doesn't work.
You are now muted.
Wonderful. Perfect. So is there any other question?
You are now unmuted.
No? Okay, wonderful. Okay, then I just ask you to start working. If there's anything wrong, just ask. If you also have problems accessing lab test 3, just write a message.
You are now muted.
And we'll stay here for another, like if you want to, we can stay here for another 45 minutes and you can just start and ask.